All right, it says test each statement below to see if it's reversible. So what we really want to do is demonstrate that, yes, the original statement is true, the original conditional is true, and then also the converse is true as well. So let's read it for number 19. A perpendicular bisector of a segment is a line, segment, or ray that is perpendicular to the segment at its midpoint. Okay. Um, so how would you say that as a conditional? You would say if a line, ray, or segment is a perpendicular bisector of a segment. So if something is a perpendicular bisector of a segment, then it is perpendicular to the segment at its midpoint. Well, by definition, yes. Okay. If it's perpendicular, that means it's crossing that line, segment, or ray that we're talking about is crossing the segment at a 90-degree angle, perpendicular, and right there at the point midway between the segment's endpoints. Okay, so let's reverse that statement and see if it's also true. Okay, if a line, segment, or ray is perpendicular to a segment at its midpoint, then it is a, the perpendicular bisector or a perpendicular bisector of the segment. Yeah, because that's what it means. Okay, that's what it means to be the perpendicular bisector, is that it's perpendicular to the segment at its midpoint. Okay, so we can write it as a true conditional, biconditional rather, by writing uh, a line, segment, or ray is a perpendicular bisector of a segment if and only if it is perpendicular to the segment at its midpoint. Now we're going to actually explore these ideas about perpendicular bisectors and things really in detail later. But right now, just um, know that that's what it means. To be perpendicular to something is to cross it at 90 degrees, and to be a bisector of something means to split it right at its midpoint into two equal parts. My apologies if you can hear the noise in the back. It's pouring rain outside, and what you're hearing is the sound of the heavy volume of water rushing through the pipe that's running in our classroom, which means our floors are getting flooded. Fun. Um, it's actually better than it used to be. They patched it up pretty well. Um, so it now only sort of leaks instead of used to where it would be a lake inside my room. Fun. So anyway, that's just what you're hearing. Now, okay. I think that I eliminated 21. And the reason that I eliminated 21, and I'll get it out of here, is because how would you know what a Tar Heel is? Okay, a Tar Heel is a person who was born in North Carolina. And a person who was born in North Carolina is a Tar Heel. So that's just a fact. So I'll do it. Why not? Let's do it. Um, but how would you know that? So I didn't require it of you because you'd be like, what? What does that mean? But that's exactly what it does mean, is that um, right? They call people born in North Carolina Tar Heels. So both the conditional and its converse are true. A Tar Heel, if a person is a Tar Heel, then they were born in North Carolina, true. If a person was born in North Carolina, then they are a Tar Heel, true. So we can say a person is a Tar Heel. By the way, the word is meaningless. Okay? Tar Heel is like, I don't know, maybe the heel of your foot is covered in tar because something about the geology of the place. North Carolina has a lot of tar. Uh, doesn't matter. It doesn't matter. That's what they call them. That's what they call them. So you go with it. Okay. Person is a Tar Heel if and only if the person was born in North Carolina. Okay, kind of silly. But anyway, let's finish up with this last one, 23, and say, it says, two angles that form a linear pair are adjacent. And so let's look at that. Okay. Two angles that form a linear pair are adjacent. If two angles form a linear pair, then they are adjacent. Yeah, that's true, actually. Um, you can't be a linear pair without being adjacent. Okay, so two angles that form a linear pair are adjacent. True. Now, what is the reverse of that? Two angles that are adjacent form a linear pair. No, that's not actually reversible because you can have two angles that are adjacent, but they don't sum to 180, so we don't say they form a linear pair. So that is the answer to this is not reversible because it doesn't work. The converse of it is not also true. So that's it. That's how you